Okay, so for the second task, can you put all these numbers on the index cards in order from smallest to largest?
Um,
Hand me that my piece of paper with my notes.
103,
Okay.
113,
All right.
130,
Mm-hmm.
1003, 1033, 10,303, 13,030.
Okay, I heard you say like 1,033, 10,303. What does that mean? Like in this problem, what do you have? What do you have? 10 of what?
10,000.
10,000s. How many tens do you have in that number? 10,303. Maybe it'll be easier in this one. How many tens do you have in this one?
In 13.
In 13,030. How many tens do you have?
100,013 and 30.
Maybe this will be easier. Can you tell me the different place values for this number?
Mm-hmm.
Okay, what are they? Can you point to them and show me?
Ones, tens, hundreds, thousands, 10,000s.
Okay, so how many tens do you have?
10,000.
Well, you told me it was ones, tens, hundreds, thousands, 10,000s, right? So how many tens do you have?
3.
3. How many tens do you have in this problem?
1.
Okay. So can you think of another way to write this number, 113, in this piece of paper? We typically write it like 113. Can you think of another way to represent that number, or another way to write it, or? 100 plus 10 plus 3.
That's
so,
what they taught me at school.
That's what they taught you at school? How can you do this problem like that? So 10,303. 10,000 plus 300 plus 3. You don't have any tens in that problem.
There is.
Oh, there are no tens. Could you write this problem with tens? Like, could you change any of these numbers to be in tens instead of maybe hundreds? Maybe I'm asking the wrong question. How many tens are in 300? Do you know how many tens are in 300?
$30.
30. Okay. Have you learned about, let's see. Can you go back? I think that's good for this one. You want to do the next one? What's the next one?
Multiplication.
Yeah.
Yes. Okay. I'm gonna take this. What is 50 times 3?
100.
She can have paper if she wants.
150.
2 times 70.
140.
24 times 10. 'Do you want to look at it? 24 times 10.
Can I use my thing that they taught me in school?
Sure.
$240.
240.
Mm-hmm.
Okay, we'll talk about how you solve that in a few minutes. 31, excuse me, times 100.
3,110.
110, or 120 times 10.
1,210.
21 times 40. Do you want to do your thing again?
Mm-hmm. $840.
Last one, 65 times 40.
$2,600.
Okay, let's go back to 50 times 3. You solved that one pretty easily in your head, didn't you?
Mm-hmm.
How did you do it in your head so quickly?
I get rid of the 0 and I did 5 times 3 is 15 and then I put this 0 over here
Where did the 0 go?
in the ones place.
You just covered it up? What does 50 times 3 mean, do you think? Is there another way we could talk about it?
Like you could do 50 plus 50 plus 50.
Okay. And that shows what?
150.
How many groups of 50 do we see?
3.
3 groups of 50. Is that another way we could think about multiplication?
Mm-hmm.
How did you know to put the 0 back?
Because you don't use it over here, so you put it over here so it's in 100 and it's not just 15.
How did you do 2 times 70 in your head so fast?
2 times 7 is 14, and then you don't use the end of the 0 and 70, so you put it over here.
How did you know not to add 0, but to put it on the end?
Because this is still 70, but you just don't use the 0, but you put it over here, because if you add it, then it'd be 14, then it'd be 70 times 2 is not 14, it's not 40.
So if you cover up the 0, what problem are we doing?
2 times 7.
And 7 right here is in what place if you just did 7, not 70? Where's the 7 right now? What place is it in?
The tens.
7's in the tens place.
Mm-hmm.
When you cover up the 0, where does the 7 go?
Ones.
So 2 times 70, how else can we write that?
70 plus 70.
And 70 plus 70, how many 1s are there?
2.
How many 1s are there? Show me the 1s, please.
There.
How many 1s are there?
2.
What's in the 1s place?
0.
0 plus
0.
is?
0.
So we have 0 1s.
Yeah.
How many do we have in a tens place?
14.
We have 14 tens. In 140, how many do we have in the tens place?
4.
We have 4 tens here. Is there another way we could say that? Looking at 140, is there another way we could say how many tens we have? What did we say in this problem? We said 70 plus 70. How many tens did we say we had?
15.
Do you think 14 tens is the same thing? We said up here in 140 there's 4 tens, but we said down here we have 14 tens. Do you think that's right? 14 tens and 140?
Yeah,
Do you think that's the same thing?
you added those 2, and that's 0, and you shouldn't add those 2. But if you had 202 of these, it would be 8 tens.
So we got the 14 from our 70 plus 70,
Mm-hmm.
and then 2 zeros from 0 tens. Let's look at 24 times 10. Do you remember how you did that one?
I used my lattice method. I did a square, and
What does the lattice method show you?
it shows you,
Were you taught that in school?
yeah, it shows you the answer to the question, the math question.
So first you drew a square?
Yeah,
What did you put on the sides?
I put the bigger number goes on top,
Okay.
and then you put on the side you put 1, and then a 0 underneath it.
How did you know what were you doing? Adding or multiplying or what? The numbers?
Well, I did 0 times 4 is 0, so I put 0 right there, and then 0 times 2 is 0, and then 1 times 4 is 4, and then 1 times 2 is 2, and then I did 0. You don't add anything up to that, so that's 0, and then 4, you can't add any more since those are 0, so you put that there. And then 2, there's nothing else to add, so you put 2, and then this is the last box, and it's 0, so.
What does the 0 represent at the top like that?
The thousands.
So how many thousands do you have in that answer?
0.
What does the 2 represent?
Hundreds.
And the 4?
Tens.
And the other 0?
Ones.
How do you know which 0 is which? That's confusing, it looks like.
Well, because up here's the thousands, and down here where you start is the ones.
Oh, they just taught you that?
Yeah, because it's like, if you just write it straight, it's like this.
Mm. So you just used your procedure to figure that one out? 31 times 100. I think you did that one in your head, didn't you? How could we think about that?
Yeah, I solved it pretty quickly because I didn't. Hold on. I did 3,000 because I knew there was gonna be more than 3 over here. So I crossed off one of the zeros, and then I put these all together, and I made 3,110.
What happened to the extra zero?
You got rid of it because you weren't gonna use it.
But remember in 50 times 3, we had to put the 0 back. Where did we put the 0 in this one? We didn't put it back this time?
Because it's not 31,000. It's 3.
Is there another way we could look at that problem?
Mm.
Let's try to rewrite 100. How can we rewrite 100 so it's easy to work with? Like, could we rewrite it using tens, maybe?
Just adding by tens.
Well, if we say this is 100, how many tens is it?
10.
100 equals 10 tens. So how do we go from tens to 100 using multiplication?
Do 10 times 10 equals 100.
10 times 10 equals 100? Could we look at maybe and do 31 times 10 and see how you do that one? How would you do that?
Like, as this.
How would you think about 31 times 10 without using your lattice method? How did we think about this one? Do you remember our 3 groups of 50? You said 50 plus 50 plus 50. Do you remember that? Could you use that same thought up here with 31 times 10? How could you think about it?
So that would make this one 31,000.
Let's just look at 31 times 10. How do you look at 31 times 10?
It's just like putting them together. You just.
What would your answer to that be?
3,110. So this
3,110?
Wait.
Should we break it down even smaller? How many ones are in 10?
10.
10 tens equals, or 110, I'm sorry, equals 10 ones, you said? So what's 31 times 1?
31.
31, you know? Because we have how many groups of 31 and 31 times 1? Just one group. So if there's 10 ones and 1 10. Oh, that sounds tough. How can we use that to think about 31 times 10? Do you think our answer is going to be 10 times this answer?
Yes.
31 times 10.
Because 31 times 10 is just like going 10, 10, 10, 10, 10, 31 times, or 31, 10, 10, 10, 31 times 10 to 31, 31, 31, 10 times.
So you said either 10 groups of 31 or 31 groups of 10.
Mm-hmm.
Let's try and write it. Let's write 31 10 times.
I'm just counting.
I have 4
1,
groups.
2, 3.
Okay, there's 4 groups. Okay, how many ones do we have when we have 31 10 times?
10.
We have 10 ones. Will you write that on the side for me, please? Just write 10 ones. How many 10s do we have?
10.
We have 10.
Adding these up.
What would you say? That's kind of like 10 30s? Yeah. So what does that
it's
give us?
30.
What's 30 times 10? Should we write it? 30 times 10?
$90. Wait. 3. 300.
330 groups of 10. And then we have to add our what? Don't forget about our ones place. How many ones do we have?
10.
So we have to add our 10 to 300. What happens when we add 300 to 10?
Equals 410.
Oh, this is a plus sign, sorry. Just 300 plus 10.
Oh. 310.
Okay, so what problem do we just do? 31 times 10?
Multiplication.
Do you remember what our original problem was?
31 times 10.
31 times 100. Remember what we said earlier? We said 100 is the same as 10 tens. And right here we did 31 times 10. I wonder how we can get from 31 times 10 to 31 times 100. How do we get from 10 to 100?
10 times 10 is 100.
So maybe we could use our answer from 31 times 10 and multiply this by 10? Do you think that would work?
To get this answer,
Yeah, what's our answer of 31 times 10?
310. I think it will work.
You think we can multiply 310 by 10? And why did we say it will work? What did we rewrite? We wrote the 100 as what?
10, 10.
So what do you think 310 times 10 is? How do you figure that one out?
You could put the 1 right in between these ones.
Why would you move the 1 like that? What's another way we could look at that? Remember we rewrote 31 times 10. You said we could have 31 groups of 10, right?
You could do 310, 300.
Do you think we could use that same method down here? We could do 310 how many times? 10 times. So that shows 10 groups of 310. How could that help with our answer? How many ones do we have there?
0.
Can you write 0 ones on the side for me, please? It's okay. How many tens do we have there? How many tens?
10 tens.
Is there another way we could rewrite 10 tens? What did we say up here about 10 tens?
100.
It equals what?
100.
10 tens is 100.
Mm-hmm.
So we could rewrite that, right, as 100 instead of 10 tens. And look at all those threes. What do those threes represent?
Hundreds.
Wow. So we have 300. How many 300s do we have?
$30.
We have 30 300s? But we only have 10 tens. How do we have 30 100s?
Oh, we have 10.
300 10 times?
Yeah.
Oh.
I just added them all up.
What's an easy way we can count 300 10 times?
Multiplying 10. If you do 10 times 10, wait, 10 times 10 times 10 times 10.
So 300 times 10, you think?
Well, if you do 10 times 10 is 100, and if you do it again, it's 200, and again it's 300.
So what we want to find is 10 groups. 10 groups of 300. What does that equal?
Groups of 30.
We have 3. You said these threes equal 300, right?
Mm-hmm.
So now we have 300 10 times, right? Can we figure that out? What that equals?
You could do 3 times 10 is 30, and add one of these zeros to it.
So what would you say that is?
300.
The 300's in our problem. How can the
Oh,
answer
you
be?
add these two zeros to make 3,000.
So you think the answer is 3,000 by adding zeros?
Mm-hmm. Or what you could do is 3 times 1
Okay.
is 3, and then just add these 3 zeros.
Oh, okay. 3 times 1. Add the 3 zeros. And so now we figured out we have 3,000 here, right?
Mm-hmm.
So how many thousands do we have?
3.
Do you remember how many hundreds we have? What did we say about our tens place?
It has 10 tens, or it's just 100.
So we called that 100 instead.
Mm-hmm.
So if we're going to call our 10 tens 100, how many tens do we have left? Do we have any tens left over?
Mm-hmm.
0? Do you remember how many ones we had left over?
We didn't have any.
Oh, we didn't have any ones at all?
Mm-hmm.
So now we have 3,000 plus 100 plus 0 tens and 0 ones. So now we're trying to solve our first problem, which was 31 times 100. What's the answer, do you think? How can we use this to find the answer?
1,000 and
31,000?
100.
How many thousands do we have here?
3.
So we have 3 thousands plus 100.
Mm-hmm.
What do you think that is?
3,100.
That's our answer?
Mm-hmm.
Yeah?
Mm-hmm.
Do you remember what you first answered when you had this question?
3,100.
Which answer do you think is correct? We had two different answers. You think that one's right?
Mm-hmm.
Why do you think so?
Because we went through everything and found the answer.
We kind of rewrote the
Mm-hmm.
tens place or the tens and the hundreds.
Yeah.
So your guess was pretty close, right? That's what you think? You think this is the right one?
Yep.
All right.
Okay. I'm gonna do this one instead. Let me skip this one. Okay, you just did that a lot.
Yeah.
Okay. That's the last one, okay? I can tell your brain is working very hard. Okay, so we're gonna talk about money, right? Suppose you have $10, okay? And you want to cash it in for dollar bills.
Mm-hmm.
How many dollars can you get for $10?
10.
10? 10?
Mm-hmm.
So how did you know that? You didn't have to write anything down. Take you about 2 seconds.
If you do 1 times 10, it's 10. So you would get just 10 $1 bills.
10 times 1 is 10, so 10 $1 bills. Okay, is there any other way you could think about that besides multiplication?
You could do subtraction too. You could do one at a time, like 10 minus 1, then again 10 minus 1 until you.
Can you draw a
help it
picture that would
random.
show me that? Like, can you draw a picture maybe on here? Like, how you do the subtraction way?
You would do it 10 minus 1.
Okay.
And then you'd get 9.
Right.
And then you do 9 minus 1.
Okay.
Mm-hmm.
So
You'd keep going until you got 0, because you want to find the exact.
can you do it
answer.
till you get 0? Because I want to see how you would know it was 10. Because well, you keep going with that, and then I'll ask you. Let's see.
What am I doing?
It's okay. Just take a minute.
Because my teacher did fractions with us this morning.
So really, here you have 1 minus 1, right? Which is what? It's 1 minus 1.
0.
Okay, so we did it, right? We counted backwards. 10
Mhm.
minus 1 is 9. 9 minus 1 is 8. 8 minus 1 is 7, etc. So when you got finished, though, it says 0.
Mm-hmm.
And you told me you had 10 $1 bills.
Mm-hmm. And
So how does that show 10? Because I see 0.
well, it shows 0 because you got the equal number. If it's 0, then you got the equal number. If you did,
Well, I'm not sure. What does equal number mean? I'm not sure what you mean.
it's like if you did 10 minus 3,
Mm-hmm.
it would get 7, and then 7 minus 3, you'd get 4. 4 minus 3, you'd have 1 extra, and you can't minus 1 minus 3. So that the 1 would be your extra number. This doesn't have any extra number.
So, if you told me that you could subtract 1 at a time, right, to get $10 bills for
Mhm.
10 $1 bills for a $10 bill.
Mm-hmm.
If you showed someone in your class this method right here,
Mm-hmm.
and you said to them, Well, for $10, I can get 10 $1 bills. And then you show them this. And they said, well, Layla, you have $0 left. You just told me I get $10. How could you use this to show them that it is $10? Can you use this?
You can get $10, but I could tell them, this is just to show you that this is the right number. That once you subtract it by ones, then you don't have any $1 bill, any other dollar bills left over. You just have $1 bills. If you wanted to divide it into one.
So is there a way you could use this to count the $1 bills you have left? Could you count any of those numbers, or?
Yeah, you could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
So if you count the one like this is $10, now you have -1 and you have $9 left. Subtract 1, you have $8 left. So each one of these ones you're telling me is representing $1 that you're gonna get. So that's how you have $10 from subtracting. So when you subtracted all of them, you counted pretty much backwards, right, by 1. You told me there's no more numbers left right here. So can you think of another way to do it? That's not multiplication, that's not subtraction. It's okay if you can't. But
Does it have to be made into $1 bills?
for right now, we want the $10 and the $1 bill. Can you think of any other strategy or any other?
Well, you could add it. Because when you get the one, you could go 1, 2, 3, 4.
Okay, so you say you could just get some
9,
and
10. Here you go.
right, like they did at the store, right? Okay, so now you have $1. Now you have $1, and you want to know how many dimes you could get for $1. I'm sorry, you have $10 bill, and you want to know how many dimes you can get for $10.
You could do $10. You could do 10 times 10 is 100. Because a dime has 10, and then you're doing $10. So
a dime has 10 what?
10 cents.
10 cents. So $10 has how many dimes?
100.
How'd you know it was 100, not 10 dimes?
Because I know that 10 dimes are in $1.
Oh, so 10 dimes are in $1. So in $10, you're telling me you have 100 dimes? Okay, and you figured that out because 10 dimes in $1 times $10.
I did 10 times 10.
10 times 10. Okay, that's how you got it. If you have $4, okay, and you want to share it with 10 people, can you figure out how much money each person might get? You can draw something if you want, or it might be easier to put your thinking on paper. So what are you thinking right now? Tell me what you're...
22 cents.
22 cents?
$4.
Whoa. So I see you doing a lot of math here. Let's see. Can you explain this part to me first, and then we'll go to this part?
I divided 4 divided by 10.
Why did you do that?
To try to get the answer.
Try to get the answer. Can you tell me what this means in words? You wrote 4 and a division sign and 10, but what does that mean in words? What are you trying to do?
4 divided by 4 divided by 10.
4 divided by 10
In words.
In words, but can you think of another way to say it in words? Like we use story problems. Like could you tell me a story problem that would work with? The problem says that we have $4 and we're sharing the money with 10 people, right?
Mm-hmm.
Okay.
A story thing, a little
Right.
problem story. 4 monkeys had 10 bananas. How could they each get an equal amount?
Very good. So we want each person to get equal amount, right, of money, and the monkeys are going to get equal number of bananas. So how did you do this one? You said 4 divided by 10, then you wrote a 0 here. What does that 0 mean?
How many times does 4 go into 1?
Oh, it goes 0 times.
And then I multiplied it. 4 times 0. I put 0, then that's 1.
Right.
Then I brought down the 0, and that makes 10.
Okay.
And then how many 4s are in 10? So I did 2, 4, 6, 8.
Okay.
So that goes into 4 times. And then, but I put the 8 down here because 2, 4, 6, 8. And then I subtracted 2. There's nothing to bring down, so I put it up here. And then 42.
You're convinced of this method, huh? You think this is the way to go?
$4.20.
Jeez, this is hard, isn't it? $4.20, but we only started with $4. How could each person get $4.20? It's kind of confusing, huh? Okay, let's see. How else could we think of 4? You told me earlier that $10 has 10. Wait. $10 has 100 dimes, right? Okay. So how many dimes would there be in $4? So we have
40.
okay, so $10. We have 100 dimes, right? And $4. We have how many?
And $4
Mhm.
we have 40 times.
40 dimes. How many pennies are there in a dollar?
100.
Do you think we could use this is 100 pennies? Do you think we could use pennies more easily than we could? Because this is kind of not really working out the way you want it to, is it? Not really. We had $22 a person, and we had $4 a person. So if we have 100 pennies for a dollar, how could you help think about how much money, how much money $4 could be dispersed among 10 people? So how many pennies do you think we'd have in $4?
400?
400 pennies. You think this could help us think about how much money 10 people would get if we had 400 pennies?
Hold on.
Can you explain to me what you're doing on your fingers? What are you trying to figure out here?
150, 100, 150, 200, 250, 300.
So you're trying to divide it into 50 cents?
Mhm.
But we have 400 pennies now, right?
Mhm.
And we're trying to divide it into 10 people. You can write on the back if you want. What's that you're writing? What does that mean? DMSB.
Add, multiply, subtract, bring down.
Oh. Did you just start learning how to do this?
Mhm.
You think that's closer than the other answers we got?
I don't know.
Okay. Did you like being interviewed for the math? Not really. Why was it hard, or why don't you like it?
It was hard, and math is not really my favorite subject.
Math isn't. Why don't you like? Why isn't math your favorite subject?
Because I'm just not really into math.
Is there a reason?
Because in our math books, and most of it's too hard.
Most of it's too hard. Do you like problems with numbers or word problems better? Which one? Like, do you think one is?
Numbers.
You think numbers are easier than word problems?
Mhm.
Do you think? Do you have when you're in school? Do you have a lot of ways that you? Like, do you draw pictures? Do you draw charts? Do you draw tables? I saw you use the lattice method. Is that what it's called?
Mhm.
And you seem to like that really well.
That's the easiest one.
It is the easiest one.
Mhm. There's partial and traditional. Other than that,
What's partial and traditional?
um,
You can use any problem you want. Let's say 24 times 10 because you used that one before. What's partial?
I don't know partial, but I can show you traditional.
Okay, that's traditional.
The traditional method
Mhm.
is 4 times 0 is 0. Then you do 0 times 2
Mhm.
is 0.
Mhm.
So then you save the place over here.
Mhm.
Then you go 1 times 4 is 4. 1 times 2 is 2. And then your answer is 240.
Hmm.
If it was different, like 93 times 76.
Okay. Oh, that looks really
You
good.
used a 10, so it's easier
Oh,
because
okay.
it just gives you the answer. And then 6.
Gives it right to you, huh?
6 times 3 is 18. You carry the 1, put down the 8.
Is that 1 or is it?
It's like here.
Okay.
9
just
times
listen.
6 is 54, and then you add the 1, so it's 55.
Okay.
And then you save your place down here.
Mhm.
7 times 3, 21.
Mhm.
Down the 2, the 1. 9 times 7 is 63.
Mhm.
Then 65. Save it with 65.
Oh.
You add them to get your answer.
Mhm.
8, 6,
Mhm.
10, 7,068.
Oh. Okay. Well, you did really good. It's been plenty long enough. Tired? Okay. We can be done. Thank you.